Hi, Yaron.
Hi, nice meeting you.
Likewise, can you tell us a few words about yourself and about the tool you want to show us?
Yeah, so I'm Yaron. I'm a founder and CTO of a company called Iguazio, which is developing tools in the MLOps space. What I'm going to speak about is the MLRun, which is an orchestration framework for MLOps, essentially trying to automate all the different steps in the MLOps process, anywhere from data gathering, building the models through automation, serving models in sort of pipelines, and finally also monitoring and retraining and all of that. So this is what we're going to speak with a live demo that shows much of what MLRun does.
So the right word for this would be ML platform, like basically I think that can take care about the entire machine learning process, right? From the description, it seems like
Yes
that.
and no. There are many, many ML platforms today in the industry. Some are more focused on interactive development of models. You know, a lot of focus on the visualization, on the experiments, and so on. Not necessarily in scale, not as an operational flow. What we are focused is on the MLOps side. So you can still do development of model and all that like any ML platform, but the real focus is how to automate the flow of building things for production, not for interactive usage of data scientists. You can do also the interactive work, but the real advantage, real focus is the automation, the scale, the work with operational data, real-time data, and not just taking a CSV file and building some experiments around it.
Okay. Sounds quite exciting. I'd love to see the demo.
Yeah, so but maybe to explain before we go into the demo, the flow, this is the MLRun.org. Again, it's open source. You can go to the Git and download. There are tutorials in Katacoda for how to install and work with MLRun. It's the best way is to install it on top of Kubernetes or manage Kubernetes because it's designed for scale. The way that the MLRun works is essentially using the concept of serverless functions as the engines for data processing, model training, or model serving. And the way that it works is that you write a piece of code, whether it's in the Jupyter notebook or in your IDE like PyCharm. You submit this code to like Git repository or something like that. The system will automatically build the containers and the Kubernetes resources for the production. So there's no need for ML engineering or DevOps in order to do that. And when you have those individual functions for training, for serving, for data processing, you can later on build workflows from those individual functions, whether these are batch workflows or CI workflows for the development and testing of the models, or real-time workflows for example, intercepting real-time data, serving models, building complex workflows like ensembles, and also at the end, all the telemetry is built into the services, so you can do things like model monitoring, resource monitoring, data monitoring, and based on the feedback, retrain your model, etc. There's a big concept of reusability. So you can build function and store them in a function marketplace, or build data features or analytic features and store them in a feature store, and later on reuse them in production. So it allows collaborative development and a lot of automation throughout the entire process. All those functions, then they could just go and sit in what we call the MLRun function marketplace. So if you want to run training jobs or serving jobs or data analytics or deep learning jobs, etc., you can just take an individual function from the marketplace with the there's full usage instruction. And I'll show in the demo how you can use one of those function. There's a lot of documentation, including examples and demos in the MLRun docs site. So you can go from there. Now let's move into a demo. In this demo, we want to show how I can work just like a data scientist, write very simple Python code, but build very powerful infrastructure without dealing with all the complexity. I won't go into deeper, more advanced scenarios of using feature store, but we'll keep it to a simple example. So what I want to show is how I build and train models using some breast cancer sample data from scikit-learn, deploy those models into production, build workflows and pipelines for it, and so on. So the way that I work, I have a project. So in MLRun, just like in Git or in PyCharm or VS Code, you have a project. It's like a directory of the different Python files or notebooks that I'm using. So I have a project, I create a project, I can register the different assets in the project, like functions and artifacts or credentials and things like that. And it will actually generate some YAML file with all those definitions. This YAML file is important for the automation. If I'm going to run automated testing, etc., in CI systems like Jenkins or GitHub, they look into this file to understand the structure of the project. So the first thing I do is essentially set a project with the different functions that I have, the data generation, the training, and the serving. The first thing I want to do is essentially execute a function. So if we're looking into the code is relatively simple Python. I have a function, just like any other Python function that you're writing, that is generating a data set. The only thing that's unique about this function that after it's finished running, it also logs the assets that were generated. It logs the data sets that we generated into the artifact repository. It's essentially a versioned repository for all the data and assets that are generated by every execution, in this case, the data generation. But you can see it's simple Python code. So I can just launch this Python code using MLRun CLI, which wraps my Python code and adds all the artifact tracking and experiment tracking, resource tracking, automation, scaling. All that is injected automatically into my code. The code can actually run on a Kubernetes cluster or locally. So if I choose the local flag, it will actually run inside Jupyter kernel. If I remove that flag, then it will essentially run as a job on Kubernetes. So the migration from running local environment or running distributed on a large-scale cluster is seamless from the developer perspective. MLRun knows how to pack the code, generate the serverless function from it, execute it, and so on. So I can use command line, or I can use an SDK function, essentially say run function, this function. These are the parameters I want to push to the function. And again, I can toggle if I want it to run locally or on the cluster. When I'm executing it using the SDK, it also has some nice Python, some nice Jupyter widgets for the reporting of the results. And I get hyperlinks into the MLRun UI, where I can actually see this is the response of that execution. I can see the view of a data set, the artifacts that were generated, the results, the different details about the execution. I can even see the code that I was executing. So everything that I'm running is automatically being tracked. The code, the inputs, the outputs, artifacts, everything is tracked and versioned automatically without adding code on my behalf. The jobs are actually Python objects, so I can query them to see what's the status. Sometimes a job is running for an hour. I can query the state, the logs. You can look into the MLRun documentation for all the details.
We have UI, right? That also shows the state.
Yes, that's the UI that I was showing here. Again, you can see all of those things in the UI, but in many cases, you're inside the client environment or an SDK, you want to immediately see the results. Or what's more important, you can actually take those results and feed them to another execution, as we'll see in a second. So I have the state, I have the outputs. So it essentially generated an artifact, a dataset artifact. Another nice thing about the SDK, it has visualization built in or conversion. So I can take the output of that job and view that as a data frame. And so immediately I can see the result as a data frame. And that's regardless if the data is in the cluster or local. So if I'm running it as a job on the cluster, I don't need to go and fetch the data from the cluster back or from S3. It's all wrapped in nice abstraction. So I'm just essentially visualizing the output of the job. The next thing I want to do with this data set that was generated is visualize. So I can take a MLRun marketplace function called describe, which if I don't know how to use it, essentially I'm just going to get the documentation. It generates a lot of different analytical charts about a data set. That's in essence. So here I can just run this describe function, but I'm providing the input for that describe function is the output of my data generation function. So essentially you can pass data pointers from one function to another. The data itself may actually reside on S3 or on a local file system. MLRun will figure all those things by itself. So I can just run the analysis, and I'm going to get a lot of different types of charts. We won't open all of those, but you can see this is the list of outputs generated. So many different plots and charts. These are just some examples of the plots that are generated by this analysis function. So I don't need to write any code. I can just grab a function that someone else did to go and analyze my data, and based on that, build my training job. Again, I could also see the same in the user interface. So there are, again, many different charts that I can just visualize from the UI. And the next thing is that I want to run training on the data set that I generated. So here I want to take the training function, very simple function. There's nothing here special to MLRun beside this single line. There is a single line that tells me, essentially, give me the model. I'm going to analyze the model automatically. Based on the analysis of the model, we're going to essentially generate the model artifact. We're going to generate charts. We're going to do all sorts of analysis on the model. The only thing that you as a developer need to do is add a single line, which add all the MLOps functionalities. It also adds auto scaling, by the way, for some of the frameworks and many other capabilities. So as a developer, you keep your code as is. You just add one line into your training job. So when I'm running this training function with the output of the previous data generation, it will run the job, and I could see all those outputs that were generated. As a user, I did not need to specify any of those outputs. Those outputs are essentially auto-logged from the framework. MLRun knows how to understand the frameworks like scikit-learn or XGBoost or TensorFlow, and grab all the metrics or the different, or generate artifacts like plots from those frameworks automatically. So that removes the need for you as a data scientist to understand how to grab all those different outputs. So this is an example that after I ran the training, I want to look into the feature importance artifact and visualize it. So you see, I just request for the feature importance artifact, and I will visualize it. Again, everything is versioned. If I'm going to run it again, I'm going to see new artifacts, and I could go in the UI and search across artifacts, compare. We will see that in a second. So it's very streamlined. As a developer, I can work. I don't have to just work on UI like in most frameworks. I can toggle between UI and development. And also later on, when I'm going to run everything in an automated fashion using CI or Jenkins or any other framework, all of those things will still work, not just interactive in the user interface through a developer environment. The next thing I may want to do is tune parameters. So this time, those 3 parameters that I have, like the estimators, the rate, and depth, I want to drive different values and see which of the experiments yields the best accuracy. So instead of passing individual values, I can pass lists in this case, and it will essentially generate all those combinations. The hyperparameter engine in MLRun is very, very advanced. This is just a very basic option. You can ask the system to essentially run the different tests across multiple containers in parallel. Essentially, it will distribute the different tests to multiple containers for parallelism. You can have different strategies, grid search, list search, random search, and so on. But this is the very basic. I'm just saying these are the different options. I want to select the model based on maximum of accuracy. And it will just run all those different permutations and produce the best iteration number 3 with the best accuracy. And that it will store all the different results, but it will promote the sort of the best result as the sort of master result of the entire execution. But you can also look into the individual, what we call iterations. So if I'm looking at the hyperparameter function output, it will essentially give me the best result. But later on, you'll see that I can list all the models in the project and see all the model objects and the individual results of each one of them. You see different runs had different accuracy. If I want to see that in a more visual way, I can just use the compare method. And here you have a parallel coordinates plot, that I can see how the different parameters impact the different outputs. And again, everything is also visible in the UI, not just in the SDK. Even in multiple UIs, it knows how to export to other systems like TensorBoard and Git user interface and other external user interfaces. So this is, I ran training, I ran hyperparameter training, I'm running comparisons and choosing the best model with the best results. The next thing that I want to do is build a serving function. MLRun supports topology, advanced topologies for serving. So it's not just a serving endpoint. You can build a workflow that starts with data preparation, data validation, serving multiple models in ensembles, taking the results, writing it to, pushing it to a database, and so on. So these are what we call the MLRun serving graphs. It's not just individual step, it's multiple steps. Here I'm going to show the very, very basic option. Essentially, I'm just taking a serving function. Serving function in this case just contains a single class for serving a model. It has two methods, one for loading the model, the other one for prediction. This serving class also does a lot of automation, things like model monitoring and data validations and many other things are built into the model serving. You just need to do the custom methods that you want to own. And what I'm doing, I'm importing that function and also adding a model, adding the model from what we already just trained into that serving function. So the same serving function can essentially host multiple models and even complex topologies like ensembles and data processing. But in this case, we're just adding a single model. We can plot the topology of a real-time pipeline. So you see just incoming data, routing, and a single model. And we can generate a simulator that will simulate our real-time pipeline. So we don't need to go and debug it in production on container. It's very hard. We could just create what we call a mock server, which is a simulator of our real-time pipeline. And we can push some test data into that simulator and see, this is, for example, listing the different models under our model serving. Or we can just ask for inference, pass some data and get the response. So once we've seen that the model actually behaves the way we want in a real-time pipeline, you see we don't need any DevOps or any engineers to build it. We can just go and build the serving topologies by ourselves. And the only thing left to do is deploy. Deploy is essentially taking the code that was just seen with all the definitions, building containers, building Kubernetes resources, auto-scaling, API gateways, security, authentication, all of that is built automatically from the definitions of the function. And eventually it just generates an endpoint on the cluster that I have. This function is also deployed in the Nucleo serverless engine. And I could just go and run requests and test this function in the user interface. But again, here I can also test the real function through the API, just invoking some API call and getting the results. So after we've done here, you've seen that we've done some data preparation. In MLRun, there's also a complete feature store, which is much more advanced, but I won't go into it now. So you have the data preparation piece, you have the training with hyperparameter tuning, with AutoML, and all that is another piece, and you have the serving. Now, we want to build a workflow that combines all of those different things into a single workflow. So here we have a workflow file. This file essentially does exactly what we've done on the individual steps. So the MLRun API works in development and in production. It's exactly the same API, no need to refactor. So what I did is I ran a function for data generation, then running the function for the training, and then running the deployment of the serving function. I can put all of that in a graph. Just the output of the first one goes as an input to the second one, and so on. So this is a pipeline. Once I build this pipeline, I can just execute it using a single command, just saying project run, the name of the workflow. I can pass some arguments to it and let it run. It's still running. But essentially, if I'm going to open a user interface, you can also see all of that in the user interface, every step of the pipeline, the inputs, the outputs, the logs of each one of the steps. And then finally, when it completes, you see you have a deployed model that you can just work with. And the other nice thing, you can tie this all into a Git. So you can, this workflow that I've just shown you, you can say every time I'm committing code or I'm changing data or it require training, this workflow will run automatically from beginning to end, even maybe on an API call. So the move from the development to a fully automated production pipeline, you see that there's not much development that needs to be done here. So most of it is done by the original data scientist or data engineer, and the DevOps team or ML engineering just needs to validate, add some things to it, maybe exceptions, security, and you're done. You're in production with real-time pipelines.
It's really cool. It's really cool.
Okay, so you understand the difference of the approach between systems that are more designed for the interactive development, and then when they finish the work, there's another team of engineers that convert the different code and artifacts and so on into production pipelines. The approach that we've taken is that the development and the production is essentially the same. That means that there is no, every time I need to change in the traditional approach, I need to do engineering effort. Here, if the production engineers want to, for example, add security, they will add security in the original code. So the next time the data scientist will go and want to add some feature or do some changes, it works on the same code that is already the production code. It minimizes significantly the effort of moving things between different departments in the organization. And this way accelerates, some of the users of MLRun, they talk about 10 times faster development to production because you eliminate this churn between the developers and the engineers, the data scientists, the data engineers, and the other engineering teams.
Yeah, that's pretty cool. That's a lot of impressive work that you put in this tool. I saw in one of the things you showed, I think it was workflow.py, and I saw there Kubeflow.
Yeah.
So do I understand correctly that you use Kubeflow as a sort of engine for executing the pipeline?
Yes. So the pipeline engines, the pipeline support multiple engines. So what we know how to do is you can actually run the same workflow if you choose an engine equal local. So the same workflow will actually run as a local process.
Mm-hmm.
It is modeled very similar to Kubeflow, so the same pipeline could run. You see, it actually has the Kubeflow decoration. So this pipeline can run as a Kubeflow job. It can run as a local job. It can run inside GitHub Action, inside Jenkins, or inside the GitLab CI. All of them exactly the same code. So, and when it's running inside the CI system, then what you'll see, I think we have it in the documentation here. It knows how to report back into the CI systems. So I don't have it here, but it essentially knows how to generate inside the pull request. It will automatically plot all the results. So it also allows you governance. So if someone is, for example, changing a piece of code and you want to see the outcome, and maybe someone needs to approve the model to production, it's all integrated with the CI system without adding a single line of code on your end.
That's pretty cool. And how difficult it is to install MLRun? Like I know that you mentioned that we need to have Kubernetes cluster. Do you have some sort of Helm chart to get started, or how do we?
Yes. So there is a Katacoda tutorials, and the Katacoda tutorials, you have several of them. The first one is the getting started tutorial. It's all only pip install. It's even without Kubernetes. So for developers that just want to play with the, obviously it's not as powerful as Kubernetes because MLRun over Kubernetes has elastic scaling. So you can run, for example, TensorFlow job distributed on 20 servers without changing, again, a single line of code. This is not possible if you're not running over Kubernetes. This is the first thing. There is also, if you want to install over Kubernetes, there is a Helm chart, and there is a Katacoda tutorial that essentially shows you how to install the Helm chart, and it installs it inside the Katacoda. You see, you need to grab some repo, and there's actually the Helm chart that we have is coming all inclusive together with some of the Kubeflow operators, like for TensorFlow, together with like NFS for a shared file system, and like Jupyter Notebook pre-installed with MLRun and all the tutorials and demos. So it's very easy to onboard the open source environment, either as a standalone process using the pip, or as something more scalable as a Helm chart on top of Kubernetes with all the different assets that you have. So this is essentially installing the Helm chart.
So if I want to install it in my Kubernetes, first I go to Katacoda, play with this in Katacoda, and then go and apply it to my own Kubernetes cluster, right?
Yes.
Using
By the way,
kubectl.
even the Katacoda is open source. So if you want to look into the Katacoda, behind the scenes, what it's doing, it's all also in the GitHub.
Oh, cool. So anyone can just go and create something on Katacoda.
Yes, and there is something very similar to what I just showed in the notebook. You have the first tutorial is covering the different. It essentially have three different scenarios. One scenario is for understanding the concept of those serverless function and so on. The second one is more in the training, and the third is more in the real-time serving. We're adding more and more tutorials. There's a lot of content, new content on deep learning, on NLP, etc. There's inside MLRun documentation, you'll find a lot of different aspects, like real-time pipelines that we've mentioned. You have many examples for like NLP processing, for building ensembles, building pipelines. This is like an advanced pipeline, okay, where we have data enrichment, some data pre-processing and validation, ensemble of couple of models, post-processing, even like error handling and tracing. So all of that is designed using a simple graph of 10 lines of code in MLRun. Think about building such real-time pipelines in yourself with Kubernetes and containers, and all of that will take weeks or months. Here it's done in a few lines of code.
That's really cool. I'm wondering, this is such a massive and big project. How many people are actually working on this?
I think there are about 50 contributors,
Oh.
and out of them, 10 are writing code intensively, and others that share from time to time.
How old is the project, by the way? It's like a year, 2 years?
2 to 3 years, and it's essentially built on top of the Nucleo serverless engine. So it has different layers. The Nucleo serverless engine is like 5, 6 years old. It's very, very popular. It's about more than 4,000 stars on GitHub. MLRun is essentially all the automation and abstraction on top of it. There's also a very advanced feature store built into MLRun that in the feature store you'll find different tutorials of how you can build a full analytical pipeline using abstraction. This is like a demo of end-to-end fraud detection across 3 different data sets, including real-time streams coming from Kafka and all the fully automated training and retraining, all of that. There's a full demo built into MLRun. All those demos are essentially just notebooks. You can just go and download them and execute them.
Yeah, please send me these links. I'll put them in the description and people can spend some time exploring more all these features. So if somebody wants to contribute, how can they do this? I think there are, like, correct me if I'm wrong, there is one way to contribute is probably create something on the marketplace, right? And the other way is maybe contribute to the actual core.
Yeah, so MLRun has again is a full open source with maintainers, with everything. You have, when you go into the repository, you have a contributing MD with all the examples of how to set up testing environment, how to write code. There's a very extensive test environment with end-to-end system tests and unit tests and so on. And you can add tests to your code. There's an explanation here how to do it. The same for the function marketplace. And even the documentation is open source. So if I want to, I found a bug in this documentation, I could just open an issue or suggest an edit on this documentation page, just like any wiki.
That's pretty cool. I wish most of the websites had something like this. Usually I have to spend time trying to figure out what's the right page in, even if it's open source, still I need to figure out what is the right page on GitHub to find the page and edit.
We have many end users that are contributing both code and documentation, because that's the advantage of being part of an open source. Another thing great about open source, because you have all the source, sometimes you don't know which parameters to use, or you end up running into a bug or something. When you have the source, it's much easier to just go and figure out what's going on. That's why we like the concept of being open source. Also,
Yeah,
there's a big advantage of the enterprise managed platform, that you don't have all the headache of the setup over Kubernetes, and you get the security and robustness and all of that. But open source is a great way to start, and also having open source it makes your life easier for debugging, for tracing, and so on.
yeah, indeed. Um, do you have any advice to anyone who is watching this?
I think start with the Katacoda scenarios. It gives you a good understanding of the overall system and how to run those different steps. There are many different demos in MLRun. If you go into, there's also a repository of end-to-end demos. So not point solution, but like this, there's things like a mask detection demo for like images. There's network operation demos for like AI ops, telemetry data, time series telemetry data. There's a real-time NLP analysis demo. You see there are many different end-to-end demos that shows the complete story, anywhere from the data processing all the way through the training, the deployment in real time, model monitoring, etc. All built as one scenario. You can clone the demo and just run through it. And
Yeah, that's pretty cool. Um, yeah, I think that's all. So maybe one thing we didn't talk about is if anyone's watching this, go to MLRun/MLRun and give them a star. This is an amazing project. They deserve a star. So if you haven't done this, go and give them a star now. And I'll get all the links from you and put them in the description. And now I just want to thank you for finding time to talk to us to do a demo. This is an amazing tool, and I think many of us will find it pretty useful. Thanks a lot.
Thank you. Bye.